Okay, so right here is our first example. It says marine life. There are over 360 different species of sharks. Some common shark species are listed below. So we see that chart with the different kinds of sharks. Then it tells the colors of those sharks, and then their average length in feet. Okay, the first problem says, what fraction of the shark species have an average length less than 6 feet? So it tells us that our answer is going to be a fraction. So when we make this fraction, the number on bottom is going to be how many total different species there are. So in our chart, how many different species do we have?
360.
There are 360 total. There are 360 total, but they want us to just look at the chart. So how many different sharks are there in that chart? There are 9 different kinds, right? You just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, how many of them have an average length less than 6 feet?
3.
The first 3, right? You see this one's 3, 3, 5, and then it's 6 less than 6? No, it's not. So only the first 3 are. So 3 out of 9 have an average length of less than 6 feet. And how else could we write 3 out of 9?
1 over 3.
That is 1/3. Absolutely. All right? 1/3. Now, number 2 says, what fraction of the shark species are a shade of blue? So now I'm looking at the color. How many of them have blue in them?
1.
There's 1 right here. And that's the only one. So what would be the fraction that have a blue?
1/9.
1 over 9. Very good. Then the last one, what fraction do not have a shade of gray? So how many of them do not say gray?
1.
1. 2.
I see 1.
1.
Yeah,
Yeah,
just
just 1.
There's just 1. Okay, so how many do not have gray? 1 out of 9. Any questions on that page? So all of our answers that we got at the bottom, those are all rational numbers. And so we're going to look at what some of the rational numbers are now. Okay, by definition, it says rational numbers are numbers that can be written as a ratio of 2 integers. Okay, so let's put that in Sand Mountain terms. What's a ratio? It's a fraction. It's a fraction of integers. Well, how can I explain integers? Those are just negative and positive whole numbers. So it's a fraction that has whole numbers on top and bottom. Right? So like when we look here, -7 over 1, that's an integer. I'm sorry, those are both integers. So that means this is a rational number. Right here, this fraction has only integers. So it is a rational number. All right? 8 over 3, those are both integers. So that's a rational number. 9 over 100, those are both integers. So it's a rational number. So all of those are rational numbers. Right here is something that would not be a rational number. If I had a fraction that was like 1.3 over 4.7, right? Something ugly like that. So you see how the number on top and bottom, those are not integers. Those are decimals. So this is not a rational number. When it is rational, that means we can write the numerator and the denominator as integers. That's when we write it as a fraction. Are there any questions about that? So now then, what if we wanted to write that as a decimal? Right here at the bottom, it tells us any fraction can be expressed as a decimal by just dividing the numerator by the denominator. Now, rational numbers have 2 things that can happen when you turn them into a decimal. The first thing is it could be a terminating decimal. So when you see the word terminate, what do you think? Okay, end. Terminate is end. So you are thinking like ending lice. All right? All right? But I mean, that's what it is end. Exterminator. They end the lice of bugs. All right? Or if you've got a, I can't remember my other example. I can't remember. Terminate means end, okay? You're coming to the end. So like the number here, 0.625, it ends. That's called a terminating decimal. Not rounded. Like there's not more numbers here than we rounded to get there. That's not how it works. If it ends, it's a terminating decimal. All right? Or the other thing that can happen is we can get a repeating decimal. So have you seen a repeating decimal before? That's a number that just keeps repeating over and over and over. So can somebody give me an example?
0.33.
Right. Whenever we write 1/3, right? That's the one that you first learn. 1/3 can be written as 0.3333333. Right? And those threes continue forever. And the way we write that is just by saying 0.3 with a bar over the top. And that bar means the threes repeat forever. That's called a repeating decimal. Anytime you have a rational number, that's a fraction that has an integer on top and bottom. If you make this into a decimal, one of those two things has to happen. It has to terminate or it has to repeat. Any questions about that? Now, what would we call a number that has a decimal that does not terminate and does not repeat? It's not called rational. It's called irrational. Very good. And we're going to talk about irrational numbers like in the next couple chapters. Okay, so here we've got a couple of fractions and mixed numbers that we're going to have to write them as decimals. So they are currently fractions. We want to write them as decimals. So I'm going to come around and help you do it on your calculator if you have one. I'll show you how to do it for each kind. If you do not have a scientific calculator, so if you've got one of my dollar calculators, the way that you do 5/8 is you just click 5 divided by 8 in your calculator. And when you do that, you should get 0.625. And that will be what it is as a decimal. You can see that's a terminating decimal. It comes to an end. If you've got a regular 4-function calculator and you've got to convert -1 2/3 to a decimal, we have to first make it an improper fraction, which means we multiply the whole number part times the denominator. So 1 times 3 is 3, and then we add this part. 3 plus 2 is 5. So we can rewrite this as -5/3, and then we put that in our calculator. 5 divided by 3. When you punch in 5 divided by 3, you should get -1.6, and that 6 is repeating. This should be your answer. Okay, right here I got 4 of them I want you to work out on your own, and then I'm going to get 4 of you at the board to write your answers. You got what?
0.75, in other words, yes, I got it wrong.
Everyone agrees it's 0.75?
Yes.
That is correct. That is correct. B. All right, we had, what did we have up there to start with?
I had 1.68, but then realized I did it wrong.
Okay, so we had a 1.68 and then changed to 4.52. Anybody get anything different? What did we get?
I got 2.6 somehow.
2.6?
I got 113.
I got 77.
How'd you get 77?
I think it multiplied. I think
You did what?
I put, so I multiplied.
I know what you did. You did 4 times 13 and added 25. You did that out of order. All right? Listen. You do 4 times the bottom. That's okay. 4 times the bottom and then add the top one. Okay? So when you do that, you should get 113. Okay, but that 113 is still over. Guys, quit talking. That 113 is over 25. So then you got to divide that. What is 113 divided by 25? It is 4.52. So that's correct. That's correct. C. It's written really small, but I think that says -0.2 with a bar over the 2, which means it's repeating. Did anybody get anything different on that one? Yes.
I got -4.5.
-4.5. Okay? That means you divided it backwards. When you get, and this is a common thing, when you were in elementary school and you had to divide, your teacher told you what? Always divide the big number by the small number. That's not true. Okay? That's over. That was just an elementary school way to try to help kids get it in the correct way. Whatever the numerator is, whatever's on top goes in first. Whatever's on bottom goes in second, every time. Right? That's good though. That's a good common misconception to talk about. And then D, 3 and 1/11. We got 3.09 with the 0.9 repeating. What do we get on that one? Does everybody agree? 34? Because you didn't finish. You do 3 times 11, which is 33, plus 1, which is 34, but that's still over 11. You have to make it an improper fraction. So now, what is 34 divided by 11?
Oh, I forgot to divide.
Yeah, absolutely. So that's going to be 3.09 repeating. A way that you can kind of check yourself. If this is 3 and some fraction, you know your final answer has to be 3 point something. It can't be anything else. Same thing here. If you got 4 and some fraction, it's going to be 4 point something. All right? Now the mixed numbers are harder because you don't have any whole number part. Right? These are just regular fractions. But when you have a mixed number and there's a 4 out front, you know your answer has to be 4 point something. Okay, now let's work this one. In a recent season, St. Louis Cardinals first baseman Albert Pujols had 175 hits in 530 at-bats. He wasn't too recent because he hasn't played in the Cardinals for like 8 years. But anyways, to the nearest 1,000, find his batting average. So how do we find batting average? We take the number of at-bats, and that number goes on bottom. That's the denominator. And then the numerator is the number of hits that he had. So how many hits did he have? 175. And how many at-bats? 530. So we would just divide those in our calculator. 175 over 530. And somebody tell me what you got. 886. 792. Anybody got any more numbers? Some people's had so many numbers earlier, it's amazing. Their calculators went so long.
Why did they give me a 2?
Well,
Give me a
you
number.
just gave you what?
They just gave me the last number was a 9.
Because some of them have more spaces on them, right? Calculators will tell you different numbers. Okay? But now, this tells me to round to the nearest 1,000. So when I think about my decimal values, all right? And I know that you learned this in 4th grade because my mom's teaching it. And I'm helping her learn it. Know your place values. Okay? So this is the tenths place. This one would be the hundredths place. And next is the thousandths. So you should round to 3 decimal places. So I like to draw a little bar like that. It helps me see where to round to. Now, when I look, the first number past my bar is a 1. So this 1 tells the 0 to stay the same. Right? If it's 5 or higher, it goes up. If it's 4 or lower, it stays the same. So the 1 tells the 0 to stay the same. So that means that my answer is 0.330. He's batting 330. Good enough to get you in the Hall of Fame. Right now I want you to try this one. In a recent season, NASCAR driver Jimmy Johnson won 6 of the 36 total races. To the nearest 1,000th, find the part of the races he won. So we're basically finding his winning percentage. So I'll give you a couple, maybe a minute to do this one. And then we'll see who gets to come work it. Okay, so we got an answer of 0.167. What do we think? Agree or disagree? Agree. I'm hearing a lot of agree. When you divide this in your calculator, you should get this, right? Or your calculator may look like this, with a bar over the 6, right? But it tells me to round to the nearest 1,000, which means I only want 3 decimal places. So I draw my little box. This 6 tells that 6 to round up. So you should get 0.167. That is correct. Very good. Any questions on that one? Okay, so when I'm looking at this problem, it tells me I've got the decimal 0.45, and I'm going to write it as a fraction. The first way I'm going to show you how to do it is if you do not have a scientific calculator. Now, if you have one of my basic 4-function calculators, they do you no good on this. None. 0. Okay? So you might as well not even have it right now. Now, to rewrite these, you must remember the place values of your digits. So this here is called the tenths place, right? Which means that's 1 over 10. This 5 is in the what place? Hundredths place. So the last decimal place that is used is the hundredths place. That means the denominator of my fraction is going to be 100. You have to use place value to find that bottom number. And then in the numerator is a 45. Well, it'll reduce. Okay? 45 over 100, those are both divisible by 9. By 5. I'm sorry. There's a problem later that they're both divisible by 9. So when I divide them both by 5, 45 divided by 5 is 9. 100 divided by 5 is 20. And so right there is your fraction, 9 over 20. So now I'm looking at 0.5 repeating, and I want to write it as a fraction in its simplest form. So I've got 3 things that I'm going to do on this problem. First, I'm going to show you the long way around. I'm going to prove to you how it works. All right? Then the next thing I'm going to do is show you a shortcut that you can remember, if you remember how to do it. And then I'll show you how to do it on your calculator if you have a Casio. It'll be even nicer for you. All right? But first, let's all go through the proof together and pay attention. So if I want to write 0.5 repeating as a fraction, we have to treat that 0.5 repeating as a variable. So we let x be equal to 0.5 repeating. Now what I'm saying is x is equal to 0.555555555 forever. Right? That's what we have. So I've got to copy that down again right here, because we're fixing to use that and do a little manipulating. So now what do I have? So what have I now formed? I have formed an equation where I have something equal to something else. Remember that giant scale we talked about earlier last week? It's a big scale. I want to keep it balanced. I can do anything to that equation as long as I do it to both sides. So I'm going to multiply the left side by 10. So what do I have to do then? Also multiply the right side by 10. That's what keeps it balanced. It's a big scale. So what is 10x times, what is 10 times x? That's 10x. And then what is 10 times 0.5555555? Okay, that make you think a little bit. What is 10 times 23? 230. What is 10 times 2.3? 10 times 2.3 is 23. What's 10 times 0.23? So what happens every time you multiply a number by 10? You move the decimal one place to the right. So when I multiply this 0.555 times 10, I'm moving the decimal one place to the right, which should give me 5.5555. Now, are there any less 5s now than there were before? No, because it went on forever. So, I mean, there can't be any less because it never stopped in the first place. So, now, I'm going to subtract an x from both sides. Again, I'm allowed to do that because I'm doing it to both sides of the equation. So before you answer this, because every class I've had so far has answered it wrong, the first person who's spoken, not to make anybody nervous here, what is 10x minus x? Somebody's got to answer it. Who's going to be brave? But nobody's got it right.
I
All day. You gonna?
X.
Oh, you gonna go for it?
9X.
That's correct.
Okay.
That's the
here,
first
that's what I
one.
was gonna say.
The first one to get it right.
Because X is 1.
Let's go, Bill. Let's go. That's 9x. It's not 10. 10x minus x is not 10. They think they just subtract the x's off. Okay? No. Remember, it has a coefficient of a 1 in front of it. So 10x minus 1x is 9x. Good job. Now, what about when I subtract x on the right side? What's 5.55555 minus x? They're not like terms. I can't subtract them. But I can use substitution because I know what x is. X is 0.555555. So I don't have to say I'm subtracting x. I can say I'm subtracting 0.55555555. That's the same thing. So now what is 5.55555 minus 0.55555? It's just 5. So 9x is equal to 5. And now then to solve for x, I'm going to divide by 9 on both sides. So that tells me x is equal to 5/9. So if I said x was equal to 0.5 repeating, and I found that x is equal to 5/9, then guess how you write 0.5 repeating as a fraction? 5/9. That is the proof. That's how it works. All right? Now, there is a shortcut that you can use. But it's still good to understand that proof. If you can understand through that, that's good. That means you're thinking about math in a logical way. Which is what I want us to be able to do. I don't want us to just say the answer because we added. Right there, steps. This place value is in the tenths place. Tenths place. And it has a repeating decimal over the top. Right? The 5s continue forever. So anytime you have that repeating bar over the top, you take whatever your denominator is supposed to be, 10, and subtract it by 1. So in this case, it would be 10 minus 1, which is 9. And then you write whatever it is up top. 5/9. All right? So let's work a couple more. Make sure you understand. If I had 0.3 repeating, how could I write that in a fraction? Well, because it's repeating, I know that the denominator is going to be 1 less than the place value. So I'm in the tenths place. 1 less than 10 is 9. And I'm going to put that 3 in the numerator. So that is 3/9, which reduces to 1/3. All right? One more example. What if I had 0.37 repeating? Now, what's the last place value that's used now? It's the hundredths place. So we would take 1 away from 100, which would give us 99. And we put the 37 in the numerator. So that reduces to be 37/99. That's the quick way. All right? Okay, right here are 4 questions that I want you to try to work. And I'm going to roll the dice, and 4 lucky winners will be chosen to come to the board to answer. Okay, let's look at some of our answers. On F, negative 0.14. I see it's written as negative 14/100. And then he divided by 2 on top and bottom to get negative 7/50. Did anybody get anything different on F? So everybody agrees it's negative 7/50. That's correct. On G, 8.75, we just have the answer written up there, which is 8 3/4. Did anybody get anything different on that one? Did anyone get 35/4? That's an improper fraction, right? But it's the same number. I think both of those are correct. I'll take either one. Okay? Your calculator can convert between the two. If you need help, let me know right after this and I'll help you. But either one of those two would be correct there. On H, we got 0.27 and both repeating. We have that written as 27 over 99. Did anybody get anything different on that one? That can reduce. What can that reduce to? 3 over 11. Both of those are divisible by 9. I ruined that earlier, right? So that does give us 3 over 11. That is correct. And then on I, I've got negative 0.4 repeating. That's written as negative 4/9. Did anybody get anything different?
Who was that?
What'd you get?
I got negative 2 over 5.
Negative 2/5?
Yes, sir.
Anybody else get anything different? Which one do you think it is?
4/9.
Okay, it should be the negative 4/9. The 2/5 means you put the 4 over 10, right? But remember, when you have a repeating bar over the fraction, over the number, then we have to decrease that denominator by 1. So don't forget that.